Hi folks, I'm Chuck Black. We are doing Quokka walkthrough, or Quokka Waka as I like to call it. We are in the 7th session, or the 7th video of our walkthrough. We're going through this init module, which gets called at startup time. We're actually looking at code that I realized, hey, I don't really need that. So right in real time, at least real time with respect to my recording of the video, I realized that I didn't really need to be doing this, but it did provide a not a swing board, but a springboard to talk about capture, packet capture, port scan, traceroute, and how all of that worked. I am going to go a little bit through the definition of how we do our remote workers, how we send messages to them. We're going to do a deep dive later, so that's not the purpose of this, but it did give an opportunity to talk a little bit about what those things are all about. In addition, I do spend a little bit of time talking about what's different ways classes are used, normal objects that are instantiated from a class definition, and the idea of a singleton and a static class, which is something that we have actually used. And I finish up, I need to talk in, what is that, the present tense, the past tense? I can't remember, but I'm recording this after I've already done it. I will be finishing up talking about this little shutdown sequence. I'm not going into great detail, but just mentioning how we attempt to do a graceful shutdown. So that's what I'm going to be talking about. Hopefully that will be of interest to you and will be helpful. And so let's get started. Okay, so let's continue with our discussion of what happens at initialization. And in order to discuss that, let's look a little bit at what Quokka does. So I'm looking at the main screen from Quokka, which shows these devices. So let's say I decide, you know what, I want to do a packet capture. So I'm going to initiate this capture and go ahead and say start capture. Now, I would normally be waiting a number of seconds for this to complete, but I'm extremely impatient, and I also might need to wait some number of minutes even in order to see packets from a particular device. But I can tell you that there's not going to be any packets that we're seeing. And so I get frustrated and I go and I say, okay, well, let me look at hosts. I want to do an extended port scan. So let me do an extended port scan on this Amazon device here in my network. Now it's going out and doing it. It says it's retrieving scan results, but again, I'm not seeing any scan results. So, you know, what's going on here? So I say, well, let me get rid of that. Let's go and do a traceroute. Traceroute is quite interesting when I look at things that are out there in the cloud, like Google's DNS. So let me go ahead and do a traceroute. And it's going to go out and it's fetching the route results. And of course, this could take a little bit of time as well because we need to allow the traceroute functionality to execute and then have it build its picture for us and send it back. But again, I'm impatient. I'll tell you, I'm not going to end up seeing anything. And you may even be peeking up here and saying, okay, whoa, look at that port scan manager. I wonder if he's going to talk about that. Well, yeah, you guessed it. I am going to talk about that. What happened here? Well, why isn't it working? I can kind of tell by looking up here. I see I only have 2 terminals going. Now, what I normally tend to do is I just tend to start Quokka, the Quokka server running, and then I do the UI, and then I usually don't have workers running unless I'm going to do something with them. And I can probably see here, okay, well, I guess I forgot to start my workers. So I'm going to go up here, start up a new terminal window. Just because I'm a little bit obsessive about stuff, I'm going to put it down here, make it a little bit smaller and skinnier and put it in a nice place. I'm going to change directory to Quokka, and then I'm going to do /run w, run workers. And workers are going to go and begin to run. You can probably see actually there's some stuff going on here. This is actually a traceroute information. You can see the port scan is happening. So actually all those things that I was impatient and didn't wait for are all happening now. Now I think I've lost my opportunity to actually get anything except my packet capture. So if I were to go back here and say, show me the packet capture, it's going to actually look and it will find some things that it captured. It did go out and do the other stuff. It did, for hosts, it did the extended port scan, but my user interface isn't connected in such a way. If I went and back and did this, if I go to hosts and I say, all right, give me, for this Amazon device, give me an, is that what I'm doing? Yeah, extended port scan for this device. It's not actually going to be giving me the old results that we saw, but it's going to be giving me a brand new set of results that it just did. And we'll talk a little bit about that. So there's my port scan, and as you might guess, if I were to get rid of this and go to services, and if I was now going to do a traceroute on Google, it will go out. You can probably see in the little background, there's a little bit of stuff going on. You probably see over here, traceroute, sent, you can see that there's information there. And sure enough, I've got this going. So the bottom line is I needed to start these workers running, but how does all of that stuff work? Well, we're going to go into that a little bit in this discussion when I do the walkthrough. Today, we're not going to go into all the details of the remote worker functionality for all of those three types of remote workers that I mentioned, but I am going to talk about how we started out. And in the course of doing that, we're going to have to talk about a couple of things. We'll be talking about object-oriented stuff. I'm going to give you a little bit of information about that. So stay tuned if you're interested. There's a little high-level discussion of that. I'm also going to be talking about messaging. Specifically, we use Rabbitmq. And furthermore, I'm going to be talking about using HTTP for actually sending commands as well as receiving results. So that's what I'm going to talk about as we go through this. So hang tight and we're going to dig into the code. And I lied. We're not going to look at the code right away. I wanted to show you this and I forgot to do that. This is a picture of remote worker communication, which is what we're talking about. And in here, there are a couple of nice pictures that I wanted to go over. And you may be saying, what is that and how could I look at something like that? Well, I'm here in my GitHub wiki. How did I get here? Well, basically, I was here at the home page for my wiki, and I said, okay, I had to extend this a little bit so that I could see remote worker communication. I clicked on remote worker communication. Here I am, remote worker communication, and here I actually have words that describe it, but I also have pictures, and I just wanted to reference that. How do remote workers work? Remember how we initially tried to do a packet capture and an extended port scan and a traceroute, and it failed? That was because I didn't have a remote worker going. And actually my remote worker, as you may have seen, is a local worker. It's actually running locally, but it uses this exact same mechanism. Now there's two mechanisms that we're going to be showing you a little bit about, and there will be deeper dives into this later on in my Quokka walkthrough, or Quokka Waka as I like to call it. This one is showing communication via Rabbitmq, which is a messaging system. And the other way to do it is via heartbeat, where it's going from the device, does a heartbeat to the Quokka service, retrieves commands that are waiting for it in the queue, actually in the database, and then goes ahead and sends those back down and executes it. But that's kind of what we're talking about here. So have this generally in your mind as we're going through this. And now, honest, we will talk about the code. Okay, so as promised, we are actually looking at the code now. We are in init. This is the startup functionality that starts when our Flask application begins. The Flask application is actually the Quokka application, Quokka server, Quokka service, whatever you want to call it. We've gone through a number of things just to really briefly review. We created our Flask application. By doing that, we got a bunch of these environment variables for various intervals. We started up our SQL alchemy and set the database, created that object that refers to our database. We defined all of our REST APIs. So this is where we defined our RESTful APIs that are being used for various things. And then we came down and remember we read the configuration information about devices, compliance, services, and workers. Then last time we talked about this thread manager functionality, which basically is going to be responsible for doing all of these threads. Our service thread, discovery thread, device thread, host thread, summaries thread, worker thread, and database maintenance threads. This thread manager thing that we created for Quokka, that I created, is actually managing all of that. And now here we are at this stuff. So this may look kind of strange to you. It may look somewhat familiar, but let's look and just try to imagine what this does. So I'm saying from Quokka.controller.capture manager, import capture manager. And if I look over here, Quokka controller, oh look, there's capture manager right there. So I see that there's a capture manager. If I look over here, portscan manager, yeah, there's one of those. Traceroute manager, yeah, there's one of those as well. And all I'm really doing here is I am going to say capture manager. I'm going to initiate or instantiate an instance of this capture manager. And I am going to then go ahead and use that for the rest of the functionality when I need to do packet captures. I'm going to initiate an instance of portscan manager, and I am going to, for doing any port scans, and I'm going to create this thing called Traceroute manager. Now, I want you to have a little bit of background in object-oriented stuff before I go too much deeper in this. So I'm going to take a moment as an aside, and we're going to talk about object-oriented stuff. Hey, guess what? I lied again. You're probably not really surprised at that. But I will admit, when I was describing to you this code, which had been highlighted previously, I was thinking to myself, wait a minute, I haven't gone back over this. It's been a number of months since I wrote this. Do I really need to be doing this? And so I commented it out, stopped everything, restarted everything all over again. And as you can see here, this works. I tried the other functionality as well, the packet capture as well as the extended port scan. And so I didn't really need to be doing that. And I'm not sure exactly why I did it initially. Code tends to go through evolutionary phases, and I started out with just doing a capture manager that was local. Then I had to change it to be remote, and then I ended up later adding port scan capability. Then another month later I added Traceroute, and so this kind of evolved, and I believe that I left this in here. And as I was talking to you, it was occurring to me that I don't really need this, I don't think, thinking about how Python does things kind of in a weird way with respect to what I'm about to describe to you, which is what I told you I would be talking about the last little segment. So we're going to go to that segment right now, but just bear in mind this stuff that I was talking about, the code that I was going over during initialization, actually, in fact, is not necessary. And I do, even though it's embarrassing for me, I figured, well, I'll just leave this in because this is a normal software development part of the life cycle. You write something and then you realize, I wonder if there's a better way to do it, or if I can get rid of some code. It's always good to get rid of code that you don't need. So that's the way it is. Let me go now to the segment where I explain a little bit about object-oriented stuff. Okay, so here's what I wanted to describe to you briefly. Now, we're not going to go into a deep dive regarding object-oriented stuff. There will be probably multiple class lessons videos in 52 Weeks of Python where I do that. There will be stuff in here in the Quokka walkthrough where I talk in a little bit more detail about it, but I did want you I wanted to preload your brains a little bit with some ideas that go along with the way that object-oriented stuff works. And so I'm going to talk about this stuff. If you're new and you're attempting to go through this, just hang on to your seats and listen and let some of it sink into your brain. If you're intermediate or you're experienced, then this may be old hat to you, but let me describe it to you anyway. This is stuff, if you're going to end up in an object-oriented world, you're going to want to know a bit about this. Now, if you've read anything about how object-oriented programming and object-oriented design works, I'm going to start down here and describe in general terms what we tend to think of. Now, normal objects, what you end up doing is you have what you see here, which is a class definition, and you define your class, and then what you end up doing is you instantiate instances of your class. So imagine that you had a class that was called device, and then you will end up, for every device, instantiating an instance of that device. So in your network, you would have as many of these objects, we call them objects once they are an instantiation of the class definition, we call them objects. Imagine these were devices in your network. Then you would take this over here, which is really, the definition is like a template, and then you create a bunch of those things. And that's the normal way of doing things. I will be showing you how you can create device or class definitions for devices which will utilize inheritance. As you can imagine, if you think about it for a second, you have a generic class of device that you could call device, and then you would have more specific class definitions such as a Cisco device or a Juniper device or an Arista device or an HP device. And even within Cisco, because have so many different types of devices through acquisition and development, then you would have an iOS device versus a Nexus device versus a CSR device, etc. So that is the kind of normal thing that people think about when you think about object-oriented type stuff. Now, the thing that we have actually gone through with the thread manager that we looked at, and also with these capture managers, which I just commented out and feel kind of silly about having that code in there, but hopefully it serves as a learning point for you guys. Those are a different way of doing things. There's not multiple of these objects that are creating. In fact, there's just one. So that thread manager thing that we did, let me see if we can peek at it. I've got too much stuff going on. So down here, if you can see right here, the thread manager that we looked at, that is going to be, there's just one of those. And we're actually only going to be referencing Capture Manager and Traceroute Manager and portscan Manager as well. And there's multiple ways to do this single item type of object. And one of the ways to do it is what you see up here, which is to create an object and to prohibit anybody from creating any more objects, so that there always is one and only one instance of the object. And that is what the word singleton is about. So if you've heard that word, if you're new, you won't have, but if you've been around the block a couple of times, that's what people are talking about. Another thing you might hear people talk about that isn't implemented all that directly, it would be what we would call a static class. And that is where you end up, like we did with Thread Manager, referring to the class itself. And in that sense, you have static members and static methods. Now, Python, other languages go to great pains to, within the language, the syntax of the language, make all of these things very explicit. Python is a little bit more loosey-goosey when it comes to stuff like that. And so we will be looking at that a little bit. We're not going to go too much further down into what we're talking about, but we will I will allow us to peek at it, since I promised that we were going to talk about the initialization of this stuff. And so even though we don't need to initialize it, as we saw in the code that I commented out, I do want you to have a little bit of knowledge of what is going on in those specific classes. So let me get rid of this. That's just fertilized a little bit of information into your brain. I'm going to get rid of this. And now we have these things. Oops, I'm looking at something else right here. Actually, this is where I was looking and saying, wait a minute, do I actually need to be initiating that in the way that I did? And the answer was no. So here's my capture manager that I've commented out, portscan manager, etc. But just for completeness, and I'm going to reference thread manager. Thread manager is an instance of a static, effectively a static class, a class that we're using in a static manner. In fact, I'm going to go down to thread manager and we're going to look at what I mean. This is static data. This data exists for the class thread manager. It's not unique for every instance. When we use self, if you're familiar with that, that's where we're doing a per instance type data. But this is one piece of data for the entire class. Now you may have noticed, I can't remember if I mentioned this, static method, all of these are static methods. It basically means that we are just going to be calling this and executing it, and there's no instance specific data. And what I mean by that, there's no self in here. So I would have a parameter called self that would refer to the actual object instance. Let me just refer us back to this picture. It would refer to the object instance. See this I'm pointing to over here down on the bottom right. Each one of these has a self variable that points to the instance where you have your own members and your own methods that are unique to that particular instance, mainly the members. In our situation, things are static. In the things that we're doing here anyway, things are static, meaning there's just one for the entire application. So that is thread manager. Just to show you, if I was to look at capture manager, you can see that there's some stuff that goes on here. Let's just look and understand what happens when this capture manager is going to begin to get invoked. And I don't want to go into the details of the Python implementation, but what we're going to end up doing is we are going to eventually open capture monitors.yaml. That is where we have a mapping from particular IP addresses to where the monitors live. And I called these monitors, really they are workers, but it's kind of the same word, capture monitors. I'm going to end up calling them workers a little bit later on. I'm going to end up calling get channel in order to do Rabbitmq. And here's where I'm translating protocol import to something that will be understandable by my where am I? I'm in capture in my packet capture mechanism. And here's where I initiate the capture. We're going to go into this in greater detail later on, but basically I get ready all of the capture information and I translate it into JSON. And then what I'm going to do, if it's Rabbitmq, I'm going to actually send a Rabbitmq message. And if the connection type is HTTP, then I'm going to set the command in the dictionary. This is where I'm going to send, put a command into the dictionary. And let me review. Let's see, do I have this here? Yeah, I do. So here's my Rabbitmq request that I would be sending in the first situation that we just looked at. And here is the situation where we're not using Rabbitmq for whatever reason, maybe firewalls, maybe these workers are truly remote. And in that situation, the worker is going to make a heartbeat periodically. And during that heartbeat, we are going to check and say, are there any commands I need to deliver? And if there are, it will get sent back in the HTTP reply. All right, so that we looked at capture manager. If I was to look at portscan manager, you would see some of this stuff is similar. And you might say to yourself, well, Chuck, I thought you said we weren't supposed to copy and paste code. And that's true. Some of this is in minor ways different. But what I should do when I go through is what I would probably do would be to create a class from which these classes derive. And in the base class, I would have some of the common stuff. Like get channel is going to be common. Find monitor is a little bit different. Of course, we're looking at portscan monitors rather than traceroute monitors or capture monitors, but there may be stuff that I could find to share. Again, I wrote this just thinking about how it grew organically and evolved. This is something that I should go back and tighten up. By the way, if you want to remember a word that is important in software development, that is the word refactor. In fact, if you come through and want to do something to a particular item here, then quite often you can right-click for something like PyCharm, and they even have something that says refactor. So there's a number of refactor options. But if you want to change the way stuff is, basically the general term, instead of saying rewrite that code, you would say I need to refactor that code. I will try to remember to put that word in a little call out, but if I don't, just put it into your mind. Refactor, that's an important word, and something I probably should take some time to do. I've been spending most of my time doing videos like this one. Anyway, here's my initiation of the portscan. As you can imagine, I'm going to be doing unique. This is unique to portscan, but I'm creating this information, and then I'm doing something similar. If the connection type is Rabbitmq, I'm going to publish a message onto the queue and hope that the worker gets it. Otherwise, I'm going to do the saving of this command in the database. And let's see, I looked at capture, portscan, traceroute manager is going to be effectively the same. Again, I read about all the monitors. They're going to be a little bit different in each one. Get channel is certainly something that could be saved because we have the same username and the same password, etc. But then when you get down here for initiating traceroute, of course the data is going to be different. I'm going to have to figure out things uniquely for doing traceroute because some of them might have HTTP at the beginning, and I need to, for doing a traceroute, obviously I don't want to have HTTP for doing a traceroute. I want to just have the host name or IP address. But again, this code here is fairly similar to what we had before. If it's Rabbitmq, then I'm calling traceroute manager .get channel, and then I'm going to be, and if it's not using Rabbitmq, then I'm going to be setting a command that can be retrieved via HTTP. So this is my a little bit embarrassing description of this code that it turns out I don't actually need. So I will wrap it up right there. We'll do a little bit of a review later, but hopefully this has given you ideas of what it is that we would be doing at initialization, and and gives you an idea that over time you find things that, okay, well, I didn't need to do it that way. Let's refactor it, there's that word again, so that it's a little bit better. And that's what I actually am in the process of doing right here. Okay, thanks. Hey, I decided to add this very last piece of the init module to my discussion today simply because it's pretty simple, not that critical, and this lesson isn't too long anyway. Basically, this is a way that I created to do an orderly shutdown. So you remember I have all these threads running in the background. There's the different discovery, host, service, device, database maintenance, etc. threads that are out there. And in order to shut them down in an organized and graceful manner, what I did was I implemented a manner of doing that. And so the way that you can invoke that when somebody does like a Control-C, in our case, it takes 2 Control-Cs in order to get Quokka to shut down for some reason. But basically you use this @exit module and you register a function, and my function is called shutdown. There you see it's defined. And basically what's going to happen is I'm going to say entering shutdown sequence. I'm going to use this thread manager that we talked about before. Remember, it has knowledge of all the thread tasks and threads that are out there running. And I'm going to set all of them to terminate. That's what I do in there. We won't look at that right at the moment. And then I go and I stop all of them. And these methods that I call actually wait for it to finish. So it stops, it waits until discovery is finished, host thread is finished, etc. And then it shuts down. That's all that is. I wanted to do that here because I'd like to get into the nuts and bolts of all the different stuff, like the views that we talked about that are right here. Go into detail about those. Go into detail about how these threads work in the background. I'm even going to eventually be talking a little bit about the JavaScript code that delivers let's see if we have it, that delivers the nice user interface and how we did that. But wanted you to just see this, and we knocked it out so that we're done with init, and we can begin to move into more stuff. Database also, I didn't mention that, but that will be next time. So yeah, hope this is useful. Hope even my error is useful and something that you and I can learn from. Thanks. Okay, so let's briefly review what we talked about. We're in the init function, and we're talking about what we do during init, which we don't need to do, as it turns out, but it did give me a chance to introduce you to these managers: Traceroute manager, portscan manager, capture manager. I showed you how they actually work, so how we do this remote worker communication. That's why we need to have those, because we're going to have to either use the HTTP way of communicating these diagnostic requests for portscan, traceroute, capture to our workers, or we can use Rabbitmq, which is a messaging functionality. So those are all functionality that we manage using these things. Turns out that we don't actually need to do this step right here. This was the thing that was unnecessary, where we actually create an instance of the object. Speaking of instances of objects, what else did we talk about? Well, we looked at this and we learned a little bit about the different types of objects that you can have. The normal ones where you create an object instance from a class definition. We talked about singleton, where you create only one, and I don't have any examples of that actually in Quokka, but maybe I'll do that just so that you get familiar with the pattern. And then we talked about static classes, which is a class definition that actually has static members and static methods, and we looked at how our managers for capture and portscan, etc., fall into that category, as well as the thread manager that we talked about last week. And we finished up with our discussion of the stuff at the bottom here, which is just things for mechanism for doing an orderly shutdown. So that will actually wrap up our init functionality. From that point on, our Quokka just sits there in the background. The threads are going to be working away, and then we'll be waiting for requests to come in through our views, either from the user interface or for other stuff that we will be looking at maybe a little bit later, the different views that we have. Hopefully that gives you more of an understanding of what we do at the tail end of the init process, and you'll have a better understanding for when we move forward and begin to dive into each of these. Thanks a bunch.